Hello, hello, Algebra 1. Welcome back to our nice day. We're going to look at the idea of negative exponents in this example. And we're going to look at it we're going to see a situation that we're modeling with an equation, and then we're going to see what would a negative exponent imply, what would it mean in the concept of the situation, and then see if we can actually use it to make calculations later on. But we want to try to make sense of it through, inquiry. So in this example, coral in the sea, a marine biologist estimates that the structure of a coral has a volume of 1,200 cubic centimeters and that its volume doubles each year. So it starts off when they measure it with 1,200 cubic centimeters, and every year that volume is doubling. And then we're asked to write an equation in the form of y equals a times b to the t, representing the relationship where t is the time in years, since the coral is measured, and y is the volume of the coral. We're going to need to figure out what a and b are. So if you recall, a is the starting value. In this case, we're talking about the starting volume, and b is the growth factor. So if we know that we start with 1,200 cubic centimeters, that's our value of a, and if it doubles each year, that means the growth factor is 2. So if y is the volume, and t is the time in years, then the volume of the coral starts at 1,200 and it doubles every year. So down here, if we're trying to find the volume, what is the volume when t is 5, 1, 0, and negative 1, negative 2? I'm going to make a table here, and I think we're going to start to see what this negative exponent is going to actually imply. So we have t and we have v. So we want to find out the volume when it's been 5 years later, 1 year later, t is 0, negative 1, and negative 2. Now, we have our equation already, so we just have to plug in 5. So if I take 1,200 times 2 to the 5th, I think that gives us 30,400. Let's just check that. 1,200 times 2 to the 5th. Oh, that's 4th. Yeah. 30,400 cubic centimeters. So what that means is 5 years after the biologist measured the coral, the volume of the structure is now 30,400, where it was only 1,200 to start with, which is a big change. And then when t is 1, that's asking us what is the volume of the coral 1 year later. So if we only double it one time, I can do that one in my head. 1,200 times 2 is 2,400. If I doubled it 0 times, then I'm just going to stay at 1,200. Which also makes sense, because remember, 2 to the 0 is 1. And 1 times 1,200 is 1,200. Now, here is where we get this idea of a negative exponent. What would the output be if I plugged in negative 1? So if I did y equals 1,200 times 2 to the negative first power, what does that mean? And let's think about it without using a calculator first. Every year it's being doubled. That's the growth factor, being multiplied by 2, multiplied by 2, multiplied by 2. So from year 0 to year 1, we're getting multiplied by 2. So negative 1 is just saying 1 year before the biologist came. A year ago, the structure was still there, it just wasn't 1,200 cubic centimeters. So if it was being doubled each year, what number, when you double it, gives you 1,200? And I think it's going to be whatever half of 1,200 is, which is 600. Now let's just check that with the calculator. Does the calculator kind of match our intuition here? if I do 1200 and I multiply it by 2 negative 1 times, which sounds kind of weird, I do get 600 that does match up. So if it's doubling each year, and the year we looked at it was at 1200, the year before it had to have been half of that, which is 600. So when t is negative 2, I think we can figure this one out too. Whatever it was 2 years ago, when it got doubled, it got turned into 600. So what number, when you double it, becomes 600? Well, it's whatever half of 600 is, which is 300. And I bet that'll check out if I do it in the calculator. 1200 times 2 to the negative 2. And that gives us 300. Perfect. And this is all cubic centimeters, and this is all in years. So what does it mean when t equals negative 2? So this piece right here, what does that mean? And that just represents the volume of coral 2 years before the biologist estimated the coral's volume. And the key here is 2 years before. I want us to really understand. So these negative exponents, it's kind of just working backwards. At least right now, we can think of it as working backwards. So if your growth factor is doubling, times 2 times 2 times 2, when you have a negative exponent, you just divide it by 2 that many times. So when you have an exponent of negative 1, you're just dividing it by 2 once. When the exponent is negative 2, you're dividing it by 2 twice. If the exponent were to be negative 3, we would just divide it by 2 a third time. So in a certain year, the volume of the coral was 375 cubic centimeters. Which year was this? Explain our reasoning. So we're trying to find out which year the volume went down to 375. Well, there's a couple ways we're going to look at this. First, we can just kind of keep using this pattern here. If I just use this pattern, I look at 1 year before 2 years. If I do 3 years earlier, it's at 150. That's not it. If I go a year before that, so if I go 4 years earlier, it should be half of 150, which is 75. We're getting closer, but we're not at 3. I'm trying to get to 37.5. So I'm getting closer. If I go to 5 years before, there it is, 375. So at negative 5 years, so 5 years before the biologist measured the coral, the volume of the coral was at 37.5 cubic centimeters. So make sure you're copying this down too in your notes. All right. Alternatively, we have this equation here, y equals 1200 times 2 to the t, and we want to find out at what t value does this equal 37.5. So another option that we could do without this guess and check game is go right to Desmos and type that in. We want to know when 1200 times 2 to the t equals 37.5. We got to use x if we're on Desmos, not t. Oops. There we go. So if I type that equation in, we can see that right here it's at -5. Now, what a lot of times I'd do instead of that is just type in the original equation. So I believe we said y equals this whole thing, and then we want to know when is the volume, which y represents the volume, 37.5. So if I bring this down to 37 years on the y-axis, we can see that it hits it at x equals -5. So that's another way that we could have saw, when at what year is it going to be 37.5 cubic centimeters of coral? That's going to be at -5 years before. So using decimals is another way of getting us that solution. Okay, so last example. So measuring meds, this is another example where we could see exponential growth, but also incorporating negative exponents. A person took some medicine, but does not remember how much. Concerned that she took too much, she has a blood test every hour for several hours. Find the amount of medicine in the patient's body when T is -1 and -3. Record them in the table below. Okay, so a person took some sort of some amount of medicine, but doesn't know how much they took and is worried about it. So they're testing out how much of this medicine is in their body every hour to be able to find out how much medicine they took initially. So if you look at this table down here, the amount of medicine in their blood is going down from 100 to 50 and then 50 to 25. So if you see the pattern here, it's being divided by 2. Divided by 2. So if that's the case, how much medicine did they have in their body an hour before? So if you look at this pattern here, we just want to go 1 hour before when they got their first blood test. So what number, when you divide it by 2, gives you 100? And if we double 100, that'll tell us that answer. So 200 is what it must have been an hour earlier because it's going down by a half. Okay? And when T is -3, be careful. So an hour before, I'm just going to kind of like slip this in here. An hour before that, so 2 hours earlier, half of what gives me 200, that had to have been 400. And so 3 hours earlier, half of what is 400, it has to be 800. Because each time we're just going divide by 2, divide by 2. So it kind of keeps us in that pattern here. So in this situation, if every hour the amount of medicine in our body is being halved, then the hour before we can get it by doubling it. What do T equals 0 and T equals -3 mean in this context? When T equals 0, this is when the person took their first blood test. And then T equals -3. This is 3 hours before the person took a blood test. Okay. So the medicine was taken when T is -5. So that means the person took the medicine 5 hours earlier than they actually had this blood test. Assume the person didn't have any beforehand. How much medicine did the person take? So we can keep going backwards. So if I go backwards to -4, we just have to double the 800, which is 1600. And if we go back 1 more hour, we just have to double that, which is going to be 3200. So they must have taken 3,200 milligrams of medicine. And we can even write an equation here that models it. So they started off at the blood test at 100 milligrams. That's right here. And then every hour, it goes down by a half. So if I plug in -5 to that, that's another option that we could do. To find out that there's 3,200 milligrams of medicine in the person's body when they took it. So that's the pill that they took. It had that much medicine in it. Mg, not My. So it asks us now to plot the points whose coordinates are shown on the table. Make sure to draw a tick mark. So what I'm going to do here is just do this on Decima so we don't have to draw it. It'll be a little bit easier. Okay. Okay. So we started off with 100. And then every hour, the amount of medicine in the body, a half of the medicine in the body remains. And that happens, let's use X. So we're just going to bring this down a little bit. And when we were asked to find out, we have when t is -5, -3, -1, 0, 1, 2, 3, something like that. So here we can kind of see all of these points. The 3,200, I'm going to shrink it a little bit so we can see that. There it is. So here, unlike the coral, this is exponential decay, not exponential growth. But that's okay. Either way, we can still get the idea of a negative exponent if the function is being decreased by a half, and we're going to go backward, we just got to double it. With the coral is being doubled. If we want to find the volume a year before the biologist came, we took half. So hopefully we're getting some idea what a negative exponent behaves like. So the kind of follow-up questions, based on our graph here, when do you think the patient will have 500 milligrams of medicine remaining in the body and no medicine in the body? So as you kind of go further and further, it looks like there's no medicine right around after 4 hours. And if we want to know when there's 500, 1, 2, 3, 4, 5, so 1, 2. So right around here is 500. So according to this graph, it's going to be somewhere between 2 and 3 hours beforehand. 2 to 3 hours before they took a blood test. So think t equals -2 to t equals -3. And then it looks like around 4 or 5 hours, there's going to be none left. Now, realistically, that's not going to be the case because there's always going to be a little bit left, but essentially none. So if I want to find out, by the way, when it's going to be 500 left, we said it's going to be between -2 and -3. The actual exact value is this number right here. Which is what we said between -2 and -3, which is nice that we can get the exact value. And then as I zoom in, although I said around 4 or 5 hours, even at 4 hours, there's still a little bit, about 6 milligrams. In 5 hours, there's still a little bit, about 3. In 6 or 7, we're at about 1.5 to about 0.75. So you can see that even though there's basically none left, there's always going to be a little bit remaining as we kind of zoom in. But anyways, the goal for today was to give you guys an idea of how negative exponents work, at least in a conceptual way. So I want you guys to finish the cool down, and I'll see you next class. Make sure to like, share, and subscribe. ring the bell for notifications. And if you have any questions, I'd love to hear it in the comments.